Hello everyone. For my CSE470 project, I am building Frontier. This is a web app that fetches papers from archive and open review, and for archive it does quality control, and for open review it serves as a tool that can slice and categorize the papers neatly. So for example, if a researcher wants to check out past work on reinforcement learning easily, they can do so using Frontier. At least that is what I'm trying to build. So let me show you what progress I made for sprint 2. Let me first create the tables on my database. Okay, so the tables have been created. Let me first run the archive fetcher. Okay, so archive fetcher, the way I have designed it is that it for the initial run it fetches 50 papers. So how does it know that it is the initial run? There's a separate table called job tracker in my database. So this is the job tracker table. Okay, so let's refresh this probably. Okay, this is empty right now. So if my fetcher cannot find a last processed marker, it will fetch 50 papers, 50 latest papers from the categories I have decided, I have hard coded in it before. And for subsequent fetches, and it will fetch 50 papers, and it will store the top of the stack. To use a stack analogy, it will store the paper at the top of the stack as a stack pointer of sorts. So for later fetches, it will fetch until it finds its old stack pointer or old top of the stack, and then and then the logic is that it will know for sure that yes, I have fetched all the papers since my last fetch. There are some edge cases and corner cases that are going to be inconvenient for this method, but I am deciding to ignore them for now. So let's see. And what is happening here is that for each paper, my fetcher is calling another reputation service, another service which talks to the semantic scholar API. So for each paper, for each author, all of his or her past publications are checked, or I attempt to check them, and I try to count the number of prestigious publications he has. So you may argue that how do you define prestige. I just used my judgment and I just use my judgment and made a collection of venues that I deem to be prestigious. So I'll just show you. So this is the archive fetcher. When it runs, it takes the help of semantic scholar service, and in the config file you can see the venues I consider to be prestigious. So these are the venues I consider to be prestigious. So, and what archive fetcher is doing here now is that it is trying to calculate the total number of prestigious publications the authors of a particular paper have, and I will use this information to formulate a reputation score for the paper itself. This is how I can rank the archive fetcher. It's not a perfect method, but it's a heuristic method, and this is my attempt at least. So we can see sometimes the rate limit hits for semantic scholar. I think we do not reach the end of his or her publication list. So in those cases 3 attempts are made. Even if we cannot get the information even after 3 attempts, we just ignore it. And another problem is author disambiguation. Many authors have the same name. I have not attempted to fix that problem. That is really difficult, and that is going to be really difficult for me, I think, to solve. So which is also, I do not think I will be able to finish my project if I put my if I try to attempt to solve that problem. Okay, so we have 50 papers now in our database, and the high water mark is just the stack pointer or the top of the stack. So this is our top of the stack right now, this paper. So for subsequent runs, the fetcher will fetch until we find this paper, and if we find this paper, we know that we have fetched all papers since our last run. The edge case is that what if the authors decide to delete this paper, then we will never find our stack pointer. In that case, there is a limit, there is a max limit of the number of papers we will fetch, even if we cannot find our pointer even after trying so much, we will just not try anymore. Okay, so 50 papers. So for archive we have fetched the 50 papers. Let's see in our database. Okay, so it's the ID, title, authors, abstract, paper URL, PDF URL, the category. So venue or category. So venue is for I built a unified table for open review and archive. So for open review paper, for archive papers, the category is stored, and for open review papers, the venue is stored here. Okay, and keywords include. So the category stores the primary category, and keywords includes all categories. And this is the reputation score column. So we can see that for this paper is okay. You can see that for this paper the reputation score is quite high. So this is the paper, multi-view 3D point tracking. So I'm guessing that this is going to be a very good paper because the authors are very prolific. So this is just my guess. And also there, so how do I actually calculate the reputation score from this information. So for that we can check out the ranking service. So I use 3 pieces of information. First is the reputation score or the reputation component, the second is the recency component, and third is the popularity component. So the reputation component is calculated from the reputation score or the raw reputation score. So the reputation the raw reputation score, I convert that to a log scale. I do that because the difference between the difference between 0 reputation score and 1 reputation score is quite high, but the difference between 100 reputation score and 150 reputation score is not that much. So we all know what the graph of or a log graph looks like. So just still, so we can see that for initially there's a sharp increase, but for for later, when the reputation score gets really high, it does not really affect the score that much. So this is just the reputation component, and okay, I will explain the other parts later. So let me run the open review feature now. So I have pre-selected the venues to fetch from, and I have selected the start year as 2024. This is going to take a while, so I will explain the ranking service a bit more. So let me just adjust this a bit. Okay, so recency is how recent the archive paper is, and just to reiterate, the ranking is only important for archive papers. It's not important for open review papers, because open review papers have already been peer reviewed. For archive papers, I weigh 0.5. I give 0.5 amount of weight to the reputation, and 0.3 amount to the recency, and 0.2 to the popularity. So recency is how recent the paper is. This also contributes to the final score of the paper, and popularity is the number of upvotes, is calculated from upvotes and downvotes. I call them underrated and overrated buttons. So the recency decay constant is 0.1. So for each day that is passed, the decay constant used is 0.1. So this is how the ranking service works, and all the scores are normalized between 0 and 100, so that they can be integrated into a final score. Okay, so you may want to skip the video for a bit, because this is going to take a while. Okay, so the fetching has finished. For the journals TMLR and DMLR, all the papers are fetched, and as they are rolling, as they accept new papers on a rolling basis, high watermark is necessary. This high watermark mechanism is similar to the one in archive fetcher. Okay, so this is done. We can have a look at Supabase. So 19,000 papers are in our database right now, and we will use these keywords to categorize our paper. So we can see that some open review papers have keywords in them, and we will use them to categorize our papers. So let's just start our server and let's just see what we built. Okay, so this is our front end. It's not that good looking right now. I'll have to fix it in sprint 3, but the important thing is that we can see that they are being ranked using the final score, and if we hover over these bars we can see the individual components. So the popularity is 100% for everyone because no votes are cast yet, so it is giving everyone a score of 100%. But we can see importantly that the reputation score is working correctly, which is the most important part. The recency scores and popularity scores can be fixed, but this is the reputation score is the most important part. So I will try to get this paper. This is now second in rank, or I'll try to get this. This is not third in rank. I'll try to get it to number 1. So I will just downvote these a bit, just upvote them. Let me just reload. Let's see. Okay, so this has come to the top, and this has gone a bit to the bottom because of the downvotes. And this has a popularity score of 100%, and the other guys have a popularity score of 0%. And the score here is the final score inside the circle. Okay, so and we can filter these archive papers based on tags. So let me if I want to check out the latest robotics papers, I will write cs.ro, and the latest robotics papers have been fetched. So these papers are the latest robotics papers. We only fetched 50 papers, so there are not that many papers in our database for archive. So okay, if I want to add an additional tag cs.lg for machine learning papers, let's see which papers contain both tags. These two papers contain both tags, so that's it. So let me check the open review papers now. Okay, so the open review papers have been fetched. These are all the TMLR papers. So let's say I want to check all the NeurIPS papers. Okay, so these are all the NeurIPS papers. Let's say I want to check them for 2024. So these are all the NeurIPS 2024 papers. Let's say I want to fetch all the oral papers. Okay, so this is all the oral papers have been fetched. There's a slight problem. The filtering by tags is missing here. I will have to fix that. So when I go to archive, so this filter by tags is an important feature. So I can select these tags I fetched from the database. So these are the unique keywords that I got from fetching the open review papers and the archive papers. So this is a useful feature, but unfortunately this is not appearing here right now. I will have to fix that later. And all the categories are not here. For example, for DMLR papers, I will show you. I'll have to select all years. I'll have to select all categories for it to work. Okay, so let me select DMLR. Okay, so this category dataset certification is not present here. Only oral, spotlight and poster are present, as I will have to fix that as well. So, and I will have to also implement user authentication. Okay, now I can click on a paper and I can go to the arXiv homepage or the abstract link. So if I just click that, it takes me to the main page on archive. I can also download the PDF. The abstract is present and I can leave a comment here. So I can say this is a paper. And this will be stored in the database. I think I commented this. Okay, let me just do another comment. Okay, there seems to be an issue here for the timing. Let me reload and see if the comments persist. Yes, so the comments are being stored in the database. Let me check. Yes, the comments are being stored. I think there's a time zone issue or something. Okay, so let me click on an open review paper. So let's click on that, and I can view. I can also leave a comment here. I can view it on open review, the main page. See. Okay, so this takes me to the open review page. And it will load and it will show all the reviews. So let me get another paper. Say I want to see this. Open review. Okay, there could be a problem with the open review servers. It's taking a long time to load. Anyways, so this is basically my Sprint 2 update. Thank you.